Hi guys, today we're talking about Chapter 4. Chapter 4 is all about force. Alright, hence my Darth Vader going on right here. Okay, so far we've learned about inertia, Newton's first law of motion, how things move. Right? We've learned about equilibrium, and if the sum of the forces equals 0, then there'll be no change in the motion. But what if there is a net force? What are we going to have then? Well, then we're going to have a change, which means we're going to have an acceleration. Right? Now, there we go. We'll have an acceleration. All right. If you remember, an acceleration is a change in velocity with respect to time. Well, that means you could change your velocity as an increase, a decrease, or you could change directions, right? Because a vector quantity like acceleration has magnitude and direction. Okay? So if we get an acceleration due to having a net force, well, we need to know how to deal with that. Right? And that's where Newton's second law comes into play. He found out the relationship between acceleration and the net force. And he also found out the relationship between acceleration and the mass. Alright? So let's think about this for a second. The bigger the force, right? That means the bigger the push or pull, the bigger the acceleration, right? The faster you can go. Right? But what if the object's bigger, has more mass? Alright? Well, if you push with the same amount of force on something that's more massive, your acceleration is not going to be the same, right? So there's how the relationship works there. And if we put that all together, you can see, well, I can highlight it here. You can see right here, Newton's second law, net force divided by the mass gives you acceleration. Alright? So with mass being on the bottom of this ratio, that means acceleration and mass have an inverse relationship. That means they behave oppositely. That means you make the mass bigger, the acceleration gets smaller. Now what about net force? It's on the top of the ratio, top of the fraction. That means it's directly related to acceleration. It means they behave in the same way. You increase net force, you're going to increase the acceleration. Right? And that's the sum of Newton's second law. I've got a video here for you that'll help you out, give you some animations to go through with that. Okay. Here's another example of Newton's second law. Okay, we're going to use this second law to discover free fall versus non-free fall. All right, we've talked about free fall, objects falling with only gravity acting on them. But we know that's not reality, right? In reality, we have some resistive forces. Right? And back, I think on slide 4, I talk about those resistive forces. Right? So you have resistive forces like air resistance, friction. All at play that's going to try to upset the equilibrium, upset the balance. Okay? So in free fall, you only have gravity acting, right? We ignore air resistance or we're working in a vacuum. Right? But again, we know this is not reality. So we investigate here how air resistance works. Right? Air resistance works against the gravity. Right? So air resistance is going to pull up on the object while gravity is pulling down, right? So it's a tug of war going on. Okay? Now, air resistance depends on two things: frontal surface area and speed. The more speed an object has, the more air resistance it has. So that means as an object's falling, well, you know it's speeding up because gravity's pulling it at an acceleration of 10 meters per second squared. So it's speeding up, speeding up, speeding up, speeding up. But that's in free fall. What's it doing in reality? It's really going to speed up, speed up, speed up. Oh, air resistance catches up with it. It starts slowing down, slowing down, slowing down until you get to this point where you reach terminal velocity. Alright? So see this picture here? Initially, air drag's smaller than the weight of your skydiver. But eventually, because the speed increases due to the acceleration of gravity, that allows the drag to increase too, until the weight and the drag are equal. Then you start falling at terminal velocity, which means falling at a constant rate. Now, still falling, but you're not accelerating anymore. Alright? So this is a good video to help you out with that. As you can see, there's some extra credit points through here. Now, if I can back up for a second, just to mention here on slide 4, here's where I talk about your resistive forces. Alright, so air resistance and friction are going to be the two main ones that we talk about in this chapter or throughout this semester, really. Alright, so make sure you understand those, read those, watch that little friction video, and it will really help you get the idea of the net forces acting. Alright? If you have any questions, as always, shoot me an email or post to your Muddiest Points forum in Moodle, and I will see you guys in lab. Enjoy.